Okay, let's talk about constant voltage characteristics, chapter 21, page 684. I'm just going to follow off the PowerPoint here for a little while. Does constant voltage power sources ensure uniform welds due to three inherent characteristics? Flow of the current to the work automatically adjusted to rate at which electrode wire is fed to work. Wire feed speed is constant, and the instant arc starting eliminates defective spots at the start of the weld. Just this last one specifically, I would like to argue with a little bit. It is very fast, instantaneous. However, you still need to be aware of how you start the welding arc. As soon as you start the arc, it's not going to be a perfect weld. It still takes about a half a second or so in order to get that weld puddle established. So as we're welding, a lot of times, if this were my welding puddle, I would try to start here. I would strike up my arc here and then come back down around and start into my weld pattern, either my backward C or my elongated ovals at that point. I would not start directly in the center because, again, there's still a lack of fusion, even though it's not like shielded metal arc welding where it takes a dramatic startup. It is fairly fast. However, there's still a lack of fusion right off the beginning. And since we have a wire feed constant speed, you have a tendency to have a lack of fusion in your starts and stops, especially with GMAW as well. So let's make sure that we maintain starting here, come back over, and then fuse back into the startup. Okay. Let's move on. The power source referred to as a constant voltage or constant potential because voltage terminals varies relatively little. We've talked about this in other ones. Feel free to read through this. Okay. Constant voltage is what we're going for. There are some points. You see something that might be an essential variable, please let me know. Any questions you may have as well. So here's the constant current. So it drops off pretty radical. The constant voltage is more of a flat slope. Okay. Pretty amazing what we can do with technology these days. Same thing as well. Okay. So all machines have a voltage control. The machine automatically maintains the arc length while the electrode feed is set at the set feed. So what this is saying is the voltage, you set the voltage, and then it'll maintain it depending on what you set your inches per minute, your wire feed speed at. If you want to alter some, you naturally need to make sure that they are in sync. Okay? There's a very limited window. They both have to be within a correct window in order to work. So if the voltage is out of range, doesn't matter what you change the wire feed speed to, it's not going to work. If the voltage is in range, you need to make sure the wire speed's in the correct range as well, because you're not just going to be able to take it anywhere and have it work. So if we're at 18 volts, our range on our wire speed, our inches per minute, might be roughly between 180 and say 250. Okay. It might even be, now we're going to get there, each machine's a little bit different. Sometimes the tension on the rollers makes a big difference, along with, if the liner's wore out, what's the contact tip look like? All these little things start adding up. We have a little bit here, a little bit of voltage loss there. Next thing you know, if you're running your wire speed at 240 at 18 volts, in order to maintain an arc and it's still not coming out the way you are, let's stop, let's look at our machine, see what we can adjust and what we can change to move forward. Okay? And get this back in the correct synchronized pattern that we need in order to produce a quality weld. So right here, constant voltage machines do not have heat adjustment like a constant current machine. So what we're referring to here is on our constant current machine, we're going to have our arc force adjustment, which is the amount of dig or heat input that we can put in. On a constant voltage machine, we don't have that option, okay? So inverters can be used for short-circuiting applications, pulse spray TIG, sub-arc, stick electrode. If you get a chance, you know, you'll be back in our welding shop and you'll weld with our new XMT 304s, and you'll open up the display panel. Man, they can do all sorts of crazy things. It's amazing what these what the inverter technology can do nowadays. So I'm going to give you a couple places that I want you to highlight or bullet point. Out of the book, 685, the output slope, that first paragraph. Again, we've talked about it before, you know, in other lectures and other courses, but I want you to take note of it again. Same page, 685, right-hand column, second paragraph down. It says the volt-amp curve of the constant voltage power source used for GMAW has a relatively flat output slope. Small changes in arc voltage result in relatively large changes in welding current. Figure 21-18 shows that when arc length shortens slightly, a large increase in welding current occurs. This increases the burn-off rate. So if you notice, what they're saying here is just a slight increase of voltage. This one creates a large increase of amperage. Okay? So that's kind of getting back to that in-sync pattern that we want to look at. Okay, after a while it'll start slowing down. You need to make sure it's slowly maintained. You can eliminate a lot of that by hand-eye manipulation. If you get it to move out there, you're kind of taking it, you're bringing this fluctuation a little bit up, a little bit down, and it helps maintain to where you can do a lot of welding. If you just weld, it's really unique. If you just like set it on there and say I welded, by the time I hit about 2 foot with no movement or no changes whatsoever, it's going to slowly decrease. And part of the reason for that is because your heat in your base metal is decreasing as well. So it's compensating for that. It's trying to compensate for it as well. Okay? So just be aware that if you change your voltage setting, if you increase your arc length, your amperage is going to go up drastically. Okay? Same as in shielded metal arc welding, it was the exact opposite. If we increased, you know, our arc length on our stick, then we increased and decreased in the appropriate proportions there as well. Okay? Talked about the types of controls. So continuous variable, voltmeter and ammeter set. Most of these machines you'll be able to check and look on them. So you can, some of them even have a test function to where you can turn the machine on. You can test to see what the actual output is as far as volts. It's important, especially to walk into a shop or anywhere, even in our shop, but to set your machine, say we're running at 18, you're going to set it at 18, and then you want to try to hit the gun and watch your needle and see what your ammeter is coming up to, and see what your display is coming out as. For the most part, that's a little bit more accurate than what you just set it to. We start to lose some efficiency. Who knows if they're still within calibration, if they need maintenance or so forth. So you might have it at 18 volts and pushing the gun, and it might only come up to like 16 volts because, you know, it's a little bit out of calibration or so forth. So at that point, you may want to turn it up to like 19 or 20 to get that voltmeter to come up to 18 where you need it to be. You need the production work to be at 18, the output at the workpiece at 18, not beginning at 18 at the machine and dropping to 16 by the time you're welding. Okay? There's other voltage controls in there as well. Those are the main topics that I want to talk about, especially, and that would be your voltage indicator, you know, what we just talked about, checking it, check your voltage indicator, see what's there, and always, naturally, always your cooling fan. Make sure that your cooling fan is clean periodically, you know, blow the thing out, unplug it, make sure everything's working good, clean the filter on it if you need to, and so forth. So in this case here, here's your voltage, here's your wire feed speed control. Now one thing that we're doing is you can flip up, a lot of machines will have different settings. Some of our newer machines will have a digital display, or they'll even give you a correct voltage readout, okay? And then they might even tell you the inches per minute. Not all machines are going to be that way. For example, this machine right here, I can see that the voltage, there's a range setting from like 1 to 10. You'll have to flip up the machine up, on this case, you'll be able to flip this door open, turn it open, and I want you to look and see where the voltage range are. So, for example, 3 might be, number 3, 1, 2, and 3. 3 might be, you may look at it and it may say it's between 14 and 16 volts. So that's not what you want. You want to be 18, so you may go to number 4 on the voltage setting. And that might be in there. So you're in that range, and then you're going to adjust your wire speed as well. So at that point you need to look at it again at the table, and it's going to give you a range at that voltage what your wire feed speed is going to be, inches per minute. So it might give you 100 to 250. So you got 150 degree range. Out of that, I want to run 40% of that 150 degree range. So I'm going to be at 40. So you know there's 60. I'm going to be 160 inches per minute. I'm going to set it at 40, and therefore, okay. So again, proportional, a percentage proportional to what that range might be. And it's fairly common to run into machines like that. Some of those older machines are still really good machines. There's still a lot of them out there. They've worked well for a lot of years, so forth. I want to take you to the book now, page 686, right-hand column. I want you to go underneath the bolded items under the pictures, and it says volt, meter, and ammeter set. These meters permit accurate, repeatable selection of weld current and voltage. Okay, it's important to kind of know. The voltage range switch, we kind of know what that is. The fine voltage adjustments, the hand control on the panel, infinite fine voltage adjustments within the range selected. Not all machines have this. Okay, so for example, I don't see this one having it at all. Some of them will, some of ours out there do, some of them don't. Okay. The voltage indicator, again, this one doesn't have one here. This one looks like it has a digital readout, but there's other machines that may have like a window with an analog needle here that may tell you what the readout is as well, and that would be your voltage indicator. Skip on down to contactor, control, receptacle, and switch. Right here. So I'm going to read from the book what it says. It's the provisions are made for a 2-conductor lead from the wire drive control to the contactor control receptacle. This completes the circuitry necessary for remote control of the welding power. The actuating mechanism for closing the circuit is the gun trigger switch. When it is closed, the primary contactor and the power source is energized. Welding power is available. Okay, now there's some other things that can be tied into the same thing. Okay, so this contactor control, it will also usually run your gas solenoid switch as well. So you're not running gas until you pull the trigger. Not only does it start the feed rolls and the electrical current coming to the end of your workpiece or your MIG gun, but at the same time it will actuate and start the gas flow within it. Now, something that's really important to know, most machines nowadays, especially in light of conserving fuel gas and so forth, say I were to make sure to listen, I wanted to listen to see if my fuel gas was running. And I'm adjusting it. I'm going to say I put it up here and I pull the MIG gun and the wire's coming out and I'm listening to my gas and I'm watching it, I'm trying to set it. After a couple seconds, it's automatically going to shut off, the gas is. Does not mean your solenoid is bad. A lot of times the solenoid will shut down unless it senses a voltage on the machine. Then in that case, it will stay running and regulated. So occasionally you'll get a problem with some porosity in there. It's usually a clean tip, or occasionally the solenoid will lose power. You'll have to stop, clean it up, grind the weld back out, give it a break. Try not to weld 5 feet in a row if you can, because that's usually when the solenoid will start to lose power. You take it apart, clean it out, and make sure that the solenoid is actuating in and out like it needs to in order to allow gas flow. Okay. I want to talk just for a minute about fixed slope and variable slope machines. We don't get into this a lot, but I can see this being something that's probably going to be more and more important as we're coming along. So slope controls, it controls the amount of current that it changes, right? It's not intended that the current be stopped, only limited. Again, this goes with the same time, especially for welding on a stainless piece of material, the coefficient thermal expansions, the CTEs as we refer to, as you start putting more heat into stainless and material, that material grows, and it grows really, really fast. So if your gap might be 1/8 of an inch, and by the time you get halfway around, say, a 6-inch piece of pipe, that thing would almost sometimes can swell shut. It will grow that much. Now stainless can be, it draws and heats up about 33% faster than normal carbon steel. So there's times if I'm welding stainless steel, I might start with my gap being only 3/32 here, but I might be 5/32 or 3/16 of a gap here. Because by the time on a 6-inch piece, by the time I start here, this thing's going to close down quite a bit, almost shut on me. So that's what we call coefficient thermal expansions. It'll draw, plus it grows at a rapid rate, okay? So this is important sometimes as you start welding. We'll get into the variable slope here in a minute. But it's going to kind of take that into consideration for you and help as well, especially if it's going to be on a mechanized system. You need to make sure that the machine is dialed in, set correctly. You're the right machine, because if it just keeps dumping the same amount of input into it, it could be catastrophic for the weld and the part. Okay? Fixed slope machines generally used for ordinary types of GMAW and mild steel. It's increase of welding currents, the upslope, decrease of currents downslope naturally. But let's talk about this variable slope. It permits the use of a wider range of wire types and sizes. Part of how that works is it adjusts the slope from flat to steep. It permits the precise control of short circuit current. As you can see, it's welded for welding a stainless steel. Here's a good one. Maybe tapped or continuously variable. Okay? So what we're showing here is the difference between the slopes. Okay? So as you notice, it starts out and then it comes down, drops off. And that can be beneficial, especially when you're welding on stainless steel. I want you to read through some of this. Make yourself comfortable with it. Come to me with any questions you have. I'm going to keep moving on. We still have quite a bit of material here to cover. Okay. So I'm going to give you a couple things in the book I want you to note. Page 689. Once you go to the top right-hand column, 1, 2, 3 sentences down on the right-hand side, the sentence starts out, keep in mind the short-circuiting mode of transfer can take place at nearly 200 times per second. That's a bulleted item, 200 times per second. Okay? Move to the next page, 690. Right-hand column underneath the titles, types of constant voltage welding machines. Okay. I want you to put a bullet point under transformer rectifiers, inverters, and then engine-driven generators. And we've discussed this in other chapters on lectures, so I'm going to bypass this as well. Page 692, underneath inverters, make sure that you highlight that first couple sentences, or the first sentences specifically. Over to engine-driven generators to the right, understand that. Page 693. Go to machine selection. Let's read from the top section of this. Left-hand column, top of the page. Constant voltage machines are used with the GMAW, MCAW, FCAW, and SAW processes. They are better suited for welding processes in which the consumable electrode wire is fed continuously into the arc at a fixed rate of speed because they permit self-regulation of arc length. Skip 2 paragraphs down. Most MIG, MAG welding is done with DCEP, which gives better melting control, deeper penetration, and good cleaning action. This is especially important in welding such oxide-forming metals as aluminum and magnesium. DCEN is seldom used. The wire burn-off rate is greater with the DCEN, and the arc instability and spatter are problems for most applications. Skip down 2 paragraphs. In italics, it starts out, spray arc welding generally requires from 100 to 400 amps for semi-automatic applications. Automatic installations may range from 50 to 600 amps. Next one, short circuiting. Gas requires only 25 to 250 amps. Flux core can go from 100 to 50 without shielding gas. With carbon dioxide shielding gas and automatic setups, current ranges from 100 to 750. So you can see there's a tremendous amount of amps that we can that can be applied as we're going through this. Okay. Okay, so we've talked about the wire feeding unit can be separate, or it can be, it's always separate, but it can be a completely separate piece of equipment, or it can be part of the same welding machine. It may be done internally. So for example, this little wire feed unit would sit on top of a power source. It's not built into the machine itself like the other one that we looked at a few minutes ago, where we pick the side of the machine up and your wire would be in there. Okay. Okay, on to the wire feeding unit control. Drives electrode wire from coil automatically. Now there are some situations with aluminum where we may have a push and a pull. So it may be pushing it from the wire feeder, but you also might have an external gear system or a roller that is helping pull it along, especially since aluminum is so flexible and ductile that if you push it 15 feet through a liner, you're eventually going to get hung up. Usually after more than 8 or 9, you're going to end up in a lot of trouble. Okay, so we want to make sure that we've got on one end of the machine